Let's say that you have to build Scrabble for Spanish users. Assuming that you don't know any Spanish, how would you approach assigning each letter a point value?
Yeah, this question I think seems kind of open-ended. So what I'll do, oh yeah, so I mentioned I can share my screen, maybe?
Yep.
Okay, so the question is basically it's about Spanish Scrabble,
Yep.
and you're asking what point values would I make or
Yep.
assign?
And for some more context, just kind of a rehash of how Scrabble works,
Oh
right?
yeah, that was the thing I was going to say next.
Yeah. So we can jump in there. Scrabble basically, right? You try to create words with the highest amount of points possible. A lot of the times, at least in English, I know like the least common letters that are placed in words, such as like something like zebra, the Z is assigned like 10 points because it's not a very common letter, right? And it's very hard to make a word with that letter. And then on the other side, all the vowels are assigned basically 1 point because they're very common and they show up in almost every single, kind of language. And so specifically, as like a data scientist, you're tasked with really trying to figure out how to correctly weight the points for Spanish, right? And so I guess given the scenario, how would we kind of approach the problem set here?
Yeah, so yeah, I'm glad because I was mentioning that it's kind of open-ended, so it's good to like say what the assumptions are going into the problem. So yeah, I guess generally, I guess for these questions, in the first step, I sometimes think of it as like I'm brainstorming. So I guess I'm trying to clarify the questions, lay down any assumptions I might have. I guess in a real interview, I might not say all these things, but in this case, I'm just saying what my thoughts are as I go. And then sort of define the priorities that I might have.
Yep.
So I think so. One thing that's sort of jumping out at me for a clarification is what's the scenario that this game is going to be played? Mainly because that changes the contingencies and the points. So is this going to be for the real world game or is this for the online game?
Yeah, I guess I'd want to know that the differences between, I guess, both there for me, actually, because I don't know what the difference is between the online and real world. But
well,
yeah.
I guess I was thinking maybe the other thing I was going to say is that I think either way I might say like maybe we should start with the online. So the reason for that, I don't actually know the differences between either them either.
Okay.
But I'm just imagining that the online would be a little easier to collect data on like just how long someone's played and just sort of metrics that we could get in terms of their engagement would be more for the online game than
Yep.
for the real world game. So we could just get more data.
Yeah. Let's say that the scope of this is for the online game because we have a lot more data that we want to collect. And then I'm guessing it also matters because of the fact that then we can kind of see on a larger scope of how we can weight these points if they might affect, outside of even the rules, just like general engagement with the game as well, right?
Yeah, that's right. We could like track people probably to some degree a little bit better. Like how often do they come back? Actually, this I guess might be related to the next point that we're maybe getting to. What's the goal of the points? And I guess the thing I was sort of hitting on before, maybe you were talking about too, is maybe it's something about engagement. I'm imagining we'd want points where such that people would be engaged with the task more. And so I guess the way we define engagement could vary. I mean, a simple thing could just be like, how often do they play in a week or 30 days? The time between gameplays, ideally, if someone feels really engaged, they'll come back and play again quickly. And so negatives for engagement would be dropped games. So we could also look at like, how often do people just drop the game? Maybe because they're frustrated or, okay, yeah. So those are maybe some options. I guess they sound good. Like for engagement. So yeah, how often do people play?
Oh, no. I was just saying that I think also the most important part of the point system is probably to set defined rules. Yeah, like I guess if we think about edge cases as kind of like a mental exercise here, what would happen if we actually made 10 points for E and like 1 point for Z? Like, would that really disrupt the engagement of the game? Or like, if we just got the points completely wrong, would that make gameplay really bad? And probably, right? Yeah.
Yeah, and I guess that's another question then too, is like how, I guess if we change the points, I guess like that could mess things up. So I guess from game to game, if you were changing the points too frequently, that could be a problem.
So that should be clarified then, right? Like, do the points get set, once as in rules for the whole thing, or is this kind of are we adjusting this on a per game basis? I would say the assumption here is probably it gets set once.
Okay, so we would, I guess the other thing I was wondering about was if you might have cohorts, like you could imagine you could set the points for a particular cohort and then a different set of points for a different cohort, or?
Yeah, that's true, actually. Yeah, so that's a good point. We could probably set points differently and then measure the engagement to see if there's any weighting there. Yeah.
Yeah, okay, so we could vary the points. But yeah, okay. Yeah, so I'm trying to think there's more, because this question is sort of open-ended, so I'm wondering if there's more stuff to clarify here. I guess one other question I'm often interested in these kinds of machine learning problems is, do we have like any baseline data or historic data? So for these points, can we make use of, so we can basically make, I think basically the thing I'm thinking about is we might want to set some sort of baseline for the points, but I think you already mentioned that, actually, I realized. So we could set sort of some baseline of the points based on sort of the frequency by which the letters occur in the language, and those could be related to the points. And so I guess I can talk about that in a little bit more detail, but I think just to start with, it might be useful to say, like, okay, so basically in general points, we'll start, maybe we can start with points that relate to the frequency of the letter in Spanish.
Yep.
I think there's a lot of details to that, but yeah, so this could be sort of a starting baseline in a way that we could figure out. And then, like we were talking about, we might have different cohorts, so we could try a few different combinations of points, maybe.
Yeah, definitely. I think that's a good baseline. I think the last one would be to understand our existing kind of data set as well, and understand what data we have to actually implement this kind of like new model here. And so, for one, there is the existing kind of Scrabble data set of, what the points are weighted to letters in the English language. And then we also have probably something like all the words from the Spanish language, that we could find and actually assign then frequencies for, that first bullet point that you have starting with the points relating to the frequency of the letter.
Yeah, I mean, you could probably even do some kind of mapping too between English to Spanish. I mean, I don't think all the letters are exactly the same, but you could even start out by saying, oh, like, let's keep the numbers sort of similar.
Yeah.
And yeah, and then for the frequency of Spanish, like you were saying, yeah, you might have some data set like a dictionary or Wikipedia, I guess. Yeah, that would be your existing data set that you would use. Yeah, so I think, and so I guess the idea here is that, again, just to repeat it, it's just so we want to correctly weight the points. And so I think based on what we've talked about, I can maybe set like a basic plan of how I might be doing this, and then I can talk in more detail about the sort of modeling and data steps. But basically, the idea is that I will figure out a set of weights lead to high engagement in Scrabble, and so I can talk more detail. I'll probably pick one of the engagement metrics. I think if I just wanted to pick one just to start with and go through, I feel like I might go with something like, I guess I'm liking the time between plays, only because that way you can sort of use each game, and then the dependent variable is the time to the next play. And so you're not averaging. Otherwise, you might need to average stuff across a week or something. So to me, that might seem nice. There's something nice about that, but I guess we can see as we go. So the idea is I'll come up with a candidate list of points, I think, based on historic data that we talked about.
Yep.
And I'll test those out in kind of an A/B test format in the different cohorts.
Okay.
To see which one leads to the greatest engagement, to see which one leads to more engagement. Yeah, I think the only one thing we might consider, I guess, is that I've defined between plays, But we might also be interested in law, because you were mentioning that, or I mean, I guess in a lot of these things, people might get excited by a change, or there might be a spike in change in usage. But we might also be interested in some long-term things. So we might want to consider also, and I'll just keep in the back of my mind, consider also having a long-term engagement metric. That sounds
So
good.
the first one is kind of like a very specific one based on like how they immediately feel kind of around the game, you think? And then the second one is more long term, like kind of retention or coming back towards, the game, and kind of like maybe weighting those equally just to make sure that you're satisfying the initial requirement of just general gameplay versus then kind of coming back and playing a second or third game, right?
Yeah, I guess we could also weight them. Yeah, that's right. So the idea is that the between games is just the more immediate thing. What happens, and what's the consequence of playing this game? I guess it matters. I think initially when I was thinking of the problem, I was thinking of like changing the weight points a lot, and so I guess each game matters a lot. But I guess in this case, because we have cohorts, it may be less relevant each individual gameplay, and so you could aggregate the information across them.
So I guess going more specifically now, let's say that you are the data scientist tasked with building the actual model. If we were to dive into like more of the nitty gritty of this question, how would you first kind of approach it? So you have kind of like your output of what you want. Now you have like your inputs of like different kinds of data sets that you own. How do we start like building the model?
Yeah, so I guess one of the things we were talking about initially was setting up the point. So I guess this is related to like kind of the process of data collection and features, maybe in a way. I think it would be too hard. I guess so. Our constraints here is probably we can't actually try every possible point combination, right? So we're somewhat limited to some number of point combinations. So we want to come up with some value that's sort of approximate. So here, I guess personally, I'd be thinking about, well, what are the possibilities that could go into the point value? So I guess we were talking, so I guess I'm focusing on the point value. And I guess to me, the one thing that pops out is that letters, just like in language in general, things, so there's units. So the letter is the individual unit, and then there's a word. So I think there's two things here I want to look at. I think one is the word level and also the co-occurrence of letters in a word and the length of the word itself. So the idea would be that shorter words are probably easier, right? And so and longer words are harder. And so if a letter, so not only, so I think one thing we definitely want to do is overall frequency of a letter in the language. And I think the next thing I'm suggesting is that there's a little complexities here because we also want to know the frequency of a letter based on the length of the word.
So this is like a variable, right?
Yeah, so this would be like kind of a second variable. And I guess those two are there. I can imagine giving weights then to letters, sort of based on each of these measures. And then the other thing I was thinking about is like the co-occurrence of letters, but I'm not sure I totally know how to assign a point value to it. I guess the idea is that maybe, like you were mentioning, the letter Z or the letter Q may tend to co-occur with certain other letters, but I'm not sure how to use that to make a point value.
Okay, so I think, those would be definitely maybe like a value of almost another model that you'd have to build, right? Where you'd have like one letter, and then you'd have maybe like the most frequent letters that show up with this letter in this language out of all the words.
Yeah.
And that also kind of brings into scope this idea of like something we should probably put ahead of time in our assumptions is the number of is the kind of frequency of each letter showing up auto-generated by an existing model, or is that something that we also have to create as well, right? Because in a regular Scrabble game, I'm sure like Z does not show up as often as like I or A, right? And maybe that corresponds to the value in the points, like it's like an inverse relationship there as well.
Yeah, so yeah, what you're saying is the constraints and the rules of the game. And so I guess, I don't know if we can do this, but you could imagine also then, that's right. So in Scrabble, some of the letters are less frequent, right, than other letters. So I guess you could imagine then you could simulate games essentially. It doesn't have to be that smart. It's just like you're drawing from your Scrabble letters, and then you're generating words. And presumably this is another question, maybe also, what's our data source for the language? But maybe I can get to it. But so say we're just drawing from a dictionary, and then we're generating words sequentially with a given hand. So assuming if we can do that, then essentially we can let like this is called like a Monte Carlo simulation. So we can do this Monte Carlo simulation multiple times, and then get, as you were saying, given a particular letter, what's the probability that it will be used in a word?
Yeah, exactly. And then I think the last thing we do have to consider is also the like frequency of a word as well, just from memory. So I'm not gonna remember a word like zeitgeist, to create when I see a bunch of words, but I probably will like see a word like book like pretty easily when I see it, right? And maybe that has to do with the frequency of the word in just regular language itself, or it has to do with just like the length and complexity of that word as well.
Yeah, so I guess that goes into this idea of this model that we generate simulating the game. So both I guess there's some probability to which you draw the letters, and then there's probabilities to which words are created. And so, yeah, I guess each word would have some probability based on its occurrence in the language. And then I guess you're just using the letters to kind of put them together in best possible ways to choose words. And yeah, so I guess what you're saying is it's more common for you to choose the shorter words than to choose the longer ones. And included with this is the frequency. I guess part of that is that longer words might also be infrequent. So I guess that combination relates to, yeah. So
I guess, taking away from all this complexity, maybe we should think of like a base case model that we could just build and then kind of iterate from there as we go on with this question, right? So let's say we have all this data, and what's the easiest kind of base case model we build, and then how do we implement that, and then maybe come back to how we can make it a little bit better.
Yeah, so I mean, what I'm imagining here now is, so based on what we're talking about, we're creating a model that simulates a game, and that simulation includes whatever the tokens you're given or the letters that you're given, and it includes some knowledge about the language, like the frequency of the words. And then from that, we can generate probabilities for each word. Presumably, we can get some kind of distribution too, so that Q has a probability to be used of like 0.1 or 0.05, but with some confidence. And I think if we take the distribution, then we could sort of just like simulate draw like different groupings of values around the probability, assuming that there's some distribution around some range, around the probability that a letter occurs in the language or is used in the game.
Okay. Could you kind of give an example of that, maybe to map it out, like maybe with the data set? So for example, you're talking about Q kind of as distribution. So maybe like include a couple other letters in there on like how you assign point value.
Okay, so say for the letter Q, we find, I'm probably totally off here on what its actual frequency is, but say we just say 0.05. The letter A, say we think its frequency is 7, and L, say somewhere in between 0.3.
Okay.
And so then I guess the idea is that these would relate. So let's ignore the variability case. So we can just talk about generating point values for one case. So these are the probabilities we're given. So then we have to actually map them to point values. And so I think if my understanding of Scrabble is right, it has like some range. It's like, is it 0 to 10 or 0 to 8?
1 to 10, let's say.
Yeah, 1 to 10. So basically you have a range of 1 to 10, and so you're just going to map these to that range. So I guess this might get a 1, for instance. This gets a 7. Oh, sorry, they're inverse. So so say this is 3, this is 10, this is like 7. And so that means like, different letters will have the same point values in this binned case. What I was then suggesting is we could generate a few other variations on these points by just sort of sampling from some kind of normal distribution for each letter. So the idea here might be that we have the letter Q, and it actually has a range. It's like 0.05. I don't know how to do plus or minus, say 0.00. Like, maybe this isn't a good example. Let me do L, because I think maybe I can have more range there. So say L is plus or minus 0.1. So that means that sometimes I could actually get 2, sometimes I might get 4. I think, I don't know if we necessarily want to overthink this. So we'll just take the number of cohorts we could do, and then just sort of generate some of these random samplings.
Okay, gotcha. And I think this kind of gets into the case of now where we're thinking of, okay, we've generated these, different cohorts, or maybe even just like one cohort with the first example. How do we know if our values are correct? Do we run simulations with the different cohorts, off of our own like kind of test data set? Or do we implement these live first? I'm sure there's probably some kind of validation step before we throw this out into the user groups, right? But if we do that, then what does that kind of validation step look like?
I don't know how you would necessarily do a validation. Maybe I'm missing something. So if your historic data is all with 1 point value system, then I guess one other thing you could have done is if our historic data is the English data set where people are playing, and I'm guessing we don't have a Spanish data set then, right? We're making this.
Yeah.
So I guess you could have used the value system. The point value system is fixed, I guess, in English. So what you could do is get the frequency that people use letters there in that language. But I'm not sure how you would, unless we have a past cohorts where we vary the value. I guess I'm not sure.
Thinking like, how do we know that we're not completely off, right? So like, let's say that we implement this and then we see like Q is like worth 2 and A is worth like 7, right? Maybe that's the extreme case, but is there any case where we like can at least validate that yes, this is a regular game of Scrabble, it's working out fine to the most part, and it's not above like some crazy variation or volatility where things are like really messed up versus just being like kind of a good normal game of Scrabble before we release the point values up.
Yeah, so I guess one thing we could do is look at the value, look at English, look at the distribution. I guess we could do the same thing we've done here in English and see if our procedure generates a similar value system as we did in Spanish. I guess so if it does, then our model seems to be generating values that would make sense in a different language that's been working and people are familiar with.
So for example, it'd be like, let's say that we've taken a normal game of Scrabble in English, right? And then we rack a couple points for each word, and we're like, okay, smart is equal to like 10 points, on average when it's played in English. Let's run the simulation for Spanish for the same word smart or whatever. And like, does it equal around like the same amount of points? Assuming that the word smart in both languages comes up at an equal amount and both, users remember that same word to the same amount as well, right? Because if I'm playing a normal game of Scrabble, then I'm not going to be like, using extreme words in one language and and other words in another language, right? Generally, I think our colloquial languages are around the same, I guess.
Yeah, I guess so. I guess you'd have to make sure if you did that the words, because I think Spanish has some other letters with symbols and stuff. So I guess you'd have to make sure that the words you're using from English to Spanish have the same letters. But yeah, I guess that makes sense. But I think the other thing that I was saying also would be reasonable is just you test the model like from ground, like you do the same thing for English. So that could be another way. But yeah, I guess those are two good ways to do sanity checks. Summary of what we said. Okay, so basically this way we have the point values, and then now, like I said, we're going to have these cohorts. So I guess we might want to make sure if we're running this in Spanish that we're like matching the cohorts as best as we can. So probably matching for like things like, I guess, demographics, age, gender, the location, these sorts of factors. And so that will then give us our data, right? So we're having the cohort do the task for a certain amount of time, and that from that we're also generating these measures. So I think one of the main ones was amount of time played, say in a week, to a month. Maybe that's. I guess we can go longer too, but yeah. I mean, the only other thing I guess maybe you might think of, but here I won't look at, but I guess you could also have surveys at the end that you collect from people to get explicit measures. But I think here our sort of implicit measure to me seems pretty good. So I think if we have that data, then the next step would be to figure out maybe something about the model that we might build. I think the goal of this model is to actually have two models in mind. So I think the more obvious one is one to just compare the different cohorts. The basic one is compare the cohorts on our engagement metric times played. And we want to be, I guess, mindful also of even if we've matched the people, right? We want to make sure that we're keeping track of our I guess covariates. So things like demographics, how long the game was, for instance, if a game was dropped, I guess we might want to also look at that because we want to make sure that these things aren't related to the engagement. It's really about the cohort between point values. It's really about the point values and not these other effects. Yeah, I'm assuming in this model doesn't seem like we have to consider anything fancy. Probably a regular regression should work. Although if it doesn't, then we could consider other types of models like a rig.
My only kind of I guess hesitancy with this is that the fact that there might be a lot more other factors that kind of engage the user besides the point values on the letters. So just like the gameplay itself, even something as dumb as the loading time on the online interface or something, or being able to match with another user. Those kind of aspects would probably affect the kind of times played metric potentially more than just the rules of the game. So if we could normalize it to that effect, then I think we'd have a better idea of how the points values actually affect the situation. Otherwise, I don't know if it'd be a very strong feature in this model. What do you think?
So how would I guess so you would normalize these different variables like times played or I guess you mentioned also the kinds of letters you get drawn.
Yeah. I think so. If we're looking at just times played, right, then it might be tough to then isolate on just the point value differentiations we're having in these games versus other factors that might be at play here. Just an engagement of Scrabble itself as a game, or other kinds of rules that could be coming up on Scrabble. And so it's kind of more so the fact that I think each game might be the reason for you to replay Scrabble might not be entirely dependent upon the point value system that was created, and it might be just completely dependent on other things, such as the person that you played against might have been really, really good, and you lost really badly, right? And so you don't want to play Scrabble again versus maybe just that point.
Yeah, so I think I don't know if this relates to what you're saying. So initially, that's why I was thinking of doing something like time between the game. So if you do the time between the game, each observation is a game itself, and then you can, assuming we can include some of the other measures you're talking about, right? Like the person who you're playing against and stuff. I guess those are we can include them as additional features. So I think if we do that, then they're all trying to predict the engagement, which could be time between games. And because each game is separate, then we can also consider the, so I guess you could do something like a hierarchical model where you consider the variance for each cohort as a separate thing, and you build a hierarchy. So it's a regression model, but it's a hierarchical regression model. So for each cohort, you have and you have players, sorry. So you have cohort and players. And so you can consider the variation that exists within a player across the games and the variation that exists within the cohort. And you're including all these covariates. Any significant difference between them now needs to take into account all these sources of variation. So I don't know if that's along the lines of what you were thinking, but I guess that I could think of that kind of hierarchical regression model.
Yeah, I think that kind of makes sense. Cool.
Yeah, so because you basically model subjects and cohorts as like random effects. And I'm wondering though if there's something else too. So I was saying that this was a simpler model, and then maybe I'll just shoot out with a more the other model I was thinking is you could do like some kind of classification type model. And then maybe the thing is our point values for each letter don't vary too much. So maybe one thing we could do is the thing that we're modeling is, so we have each letter is a regressor, and we're trying to predict each letter's point value is a regressor, and we're trying to predict the engagement.
Okay.
And so I guess we do have a limited range, but we do have a range. So I imagine you could run some model with all these covariates all in there, and you're trying to predict engagement with covariates. And then maybe what you do is you make a plot, maybe where a plot that shows maybe on x-axis is a letter value range, and the y-axis is engagement. And so maybe this is also related to what you were thinking about, is some engagement score. And so there so that plot ideally is controlling for the other things, and you're just seeing the sort of how each point value is related to engagement.
Okay, gotcha. Yeah, that makes sense. And I think this kind of, I want to wrap this up and kind of say that this kind of puts it on like a interesting perspective, because sometimes I think there's two aspects of like how we can think about this problem, right? One is that we are maybe completely redoing Scrabble from scratch into like another culture or language, and we have to understand how they value, like engagement of playing the game. Like maybe, for example, Scrabble in Spanish is like way more intellectually provoking than the English version, or like the average person who plays Scrabble in Spanish like knows a lot of different words, versus like the average person in English, doesn't know as many words or something like that. Right. And so I think like, do we do that, or are we doing something where we're recreating the exact game mechanics that we know work for English over to Spanish, and just doing a direct translation and just copying over like, the formula for exactly how we create the point values, because we know the existing game mechanics work, right? So it's like two kind of different, I think, ways of thinking about the problem. Probably not a right answer there, but like really interesting to dive into like how each one might work. And I think we've done a pretty good job with like maybe the first version, parts of the second one as well.
Yeah, I think that makes sense. I think, there's other things to explore. Like you could ask people more survey-based questions to get a sense of, to explore like how they play with the game, they engage with it. Maybe there's also, like you're saying, there's something different about Spanish players who play Scrabble online, for instance, that's different than English players.
Cool. Awesome.